Hi and welcome. The question that we are going to discuss today is from the PrepBytes contest arena from the interview preparation marathon logic building contest. Okay, so this is a marathon. So first was logic building, then we have arrays on 19th April, then strings, then recursion and sorting, searching, so on. You can check the schedule by just clicking here. Okay, so this is the schedule for it. Now we will go to the logic building part of the interview preparation marathon, and we are going to discuss the last question, that is the prime function question. Fine. So you can access this question from the practice problems, that is just go to the site, create your account, and in the fundamentals, in the practice question you can find it out. So just go to competitive coding, fundamentals, and the prime function question. Okay, so let us discuss the problem statement first. What is the problem statement, and then we will move on to the logic building part. So let's see the problem statement. So let function s prime a, so we have a function s prime, fine, gives the set of prime divisors of a. So for example, if my s prime is 300, so the prime divisors of 300, that is nothing but 2, 3 and 5. So if my s prime, let's say, is 225, so the prime divisors of 225 will be 2, 3 and 5. Fine. So this is nothing but the s prime. It gives the set of prime divisors of a. Let a function g prime. Now we have another function g prime a comma b. So what it gives? It gives the maximum possible integer b raised to the power of c, where c is an integer such that a is divisible by b to the power of c. So a mod b to the power of c is 0. Fine. So a is divisible by b to the power of c. What is the meaning of this is, let's say my g prime is 75,5. So a value is 75 and b value is 5. So in this particular case, what will be my value? That is b raised to the power of c. So 5 raised to the power of something, such that this number 75 should be divisible by this number. So if we do 5 raised to the power of 1, so 75 mod 5 is 0, it is fine. But is this maximum? So 75 mod 5 to the power of 2 is 25. So yes, it is divisible. 75 mod 5 to the power of 3, 125, it is not divisible. Okay, so the maximum possible answer is when 5 is raised to the power of 2, which is nothing but 25. So g primes gives such a number. Okay, you can see another example also. Another way to see this is 75 divided by 5 will give me 15. 15 divided by 5 will give me 3. So 75 can be maximum divided by 5 by 2. So therefore 5 to the power of 2. In the second example, 24 divided by 2 will give me 12, 12 divided by 2 will give me 6, and 6 divided by 2 will give me 3. Now it cannot be divided by 2 further, so it is nothing but 2 to the power of 3. That is nothing but 8. Fine. So it is nothing but g prime. So let's now move on to the another definition. So here we have f prime. So what f prime says is f prime of a comma b be the product of g prime, be the product of g prime. Okay, so the product of g prime b comma q for all q in s prime, for all the prime factors of a in s prime. Okay, s prime contains prime factors of a. So for all the q that is belonging to the s prime of a, okay, we need to calculate the g prime of b comma q, and we need to multiply to get the f prime of a comma b. Fine. So understand it, just read it out, take some time and understand this part. So what is f prime? Let's say for an example of 300 comma 75. So this is a and this is b. So first calculate s prime of a. So s prime of a is nothing but s prime of 300, which we have already seen, 2, 3 and 5. Fine. Now first g prime of b. B is nothing but 75 comma 1 by 1 all the factors, 75 comma 2 multiplied g prime of 75 comma 3 multiplied by g prime of 75 comma 5. Now just calculate g prime of all these values. So once we calculate g prime of all these values for 75 and 2, the value will be nothing but 75 cannot be divided by 2, so 2 to the power of 0. Now 75 can be divided by 3 at once, so 3 to the power of 1, and 5 can divide 75 2 times, that we have seen, so 7 is 2. So the answer becomes nothing but 1 into 3 to 25, which is 75 itself. Okay, now you can see for f prime of 225 and 35 also how this value came. What the question is asking us, that now they have given us the definitions of s prime, the definition of g prime, and the definition of f prime. What the question is asking us is, if we give you two numbers a and n, can you calculate f prime of a comma 1 multiplied f prime of a comma 2 multiplied f prime of a comma 3 such so on till f prime of a comma n, the whole with modulo 10 to the power of 9 plus 7. Okay, remember what is f prime. F prime in itself is the multiplication of all the g prime, okay, of b comma q, where q is nothing but belongs to the set of s prime of a, correct? So you have to understand the question first very clearly, what a question is asking. Okay, after this we can see that here is nothing but our sample test cases. So sample test cases will really help in clearing the examples. So if a equals to 300 and our n equals to 6, so what the question is asking is, it is asking f prime of 300 comma 1 multiplied by f prime of 300 comma 2 and so on till f prime of 300 comma 6, multiplication of all the f primes. Okay, now for 300 comma 1, what is f prime? So it is nothing but the s prime of 300 and it is the multiplication of g prime of 1 comma all the possible numbers, that is 2, 3 and 5 in the set of f prime. So g comma 1 comma 2 multiply g prime of 1 comma 3 multiply g prime of 1 comma 5. Fine. So this will give me this, the first value. This will give me the first value. Okay, so on we will calculate the value of the second and the value of all the third, fourth, fifth and sixth, and you will get the answer as 720. Okay, so this is what the question is. So it is asking us the multiplications of f prime, and it is given us what is f prime, what is g prime and what is s prime. Okay, the constraints in these questions are very high. So a value can be 10 to the power of 9 and n value is 10 to the power of 18 and t is 10 and the time limit is just 1 second. So this is also a very big hint. So when we have such a high constraints and the time limit is small, that means there is some mathematics going on, there is some pattern, there is some observation that needs to be made. Okay, we cannot have an order of n also in this particular case. Fine. So because a and n values are so high, so while calculating the prime factors, prime numbers, so we have to keep this in mind. So since this is high, okay, just first only just think of a mathematics, think of a pattern that can be formed. Okay, if for each and every f prime we are going on to calculate g prime, okay, the time complexity is obviously going to increase. Okay, we cannot have an n log n or n root n time complexity in this particular question. Fine. So this was the problem understanding part. Next we will see the logic building part, and we are going to do some mathematics first in this. Okay, so once we do the mathematics, the problem will be simpler, and after that we will move on to the implementation part. Okay, so let's start with the logic building. So let's see some maths part first. So in this case, if I have a number x, okay, and it is divisible by a, and I have a number y, it is divisible by b, so I can write x equals to a multiplied by some constant and y equals to b multiplied by some constant. So if I multiply it, so x into y will become a into b, let's say c1 c2 multiplied by c1 multiplied by c2. So c1 into c2 will become x upon a multiplied by b upon, sorry, y upon b. Fine. So we can say that if a divides x and b divides y, then a into b divides x into y. Fine. So this is the first result that we need to take care of. So if I give you an example, it is 25, it is 5, and it is 12 and 3. 25 into 12 upon 5 into 3 will also be divisible. Okay, so this is common. So this was the first that needs to be taken care of. Just think about, just keep this in mind. Okay, let's see the second one. So let's see the second point. Now in this point, you should know about the trailing zeros. In a factorial, how to find the number of trailing zeros. From that algo we are choosing some part. Okay, now for example, if I want to find how many zeros are there in 100 factorial, let's say base 16. Okay, so base 16 is 2 to the power of 4. So the formula here is nothing but this power 1 upon 4 summation of k equals to 1 till infinity. Okay, and the value of n that we are having, this n is 100 upon the prime factors that we need, p to the power of k. Okay, so what is this? So let's say p value is 2, so it is nothing but 100 divided by 2 plus 100 divided by 4 plus 100 divided by 8 plus 100 divided by 16 and so on till a division is possible, that is still 100 divided by 64. Okay, so this value comes out to be around 97, and we have to divide this whole number by 1 upon 4. So 97 by 4 will give you the number of trailing zeros in 100 factorial base 16. So we actually are concentrating on this part, fine. So we will be using this. So if we have n factorial p, okay, now it is nothing but, if I want to find n factorial p, a function of n factorial p, so it is nothing but summation of I equals to, or k equals to 0 to infinity, okay, n upon p to the power of k, where p is nothing, p will be, I will explain, p will be nothing but all our prime factor set, that is s prime. All the prime factors present in s prime is this. Now I want to find out how much p contributes to the n factorial. So this is how we will find out how much p contributes to the n factorial. Fine. So this is a prerequisite for this. We will try to make this video as soon as possible on finding the number of trailing zeros. Okay. So after this two mathematics part that we have just seen, now let's move on to our problem statement. Okay, the logic part. Okay, so let's begin. So here g prime of a comma b will give me b to the power of c. Now I do not know what c is. Okay, so let me just write a function for c. Let's say the function for c is d a comma b. Okay, so it will calculate c. So d of a comma b will simply become log to the base b of g prime a comma b. I hope you remember the logarithmic properties. I just logged on both the sides, c come below, so that means d a comma b comes below. Okay, so let me just show you. So log to the base b and g prime and equal to log to the base b to the power of c. So c will come here, and what is c? C is nothing but d a comma b, the function, and this will become 1. Okay, so this we can easily see. Now let me have another number. So it is a comma b, so let the another number be y comma b. Okay, so it will be log b g prime y comma b. Fine. Okay, now after this let's just add these 2 points. So if we have d a comma b plus d y comma b equals to log b g prime a comma b plus log b g prime y comma b. Now what will happen? Can you guys think about it? What is the log property of log a plus log b? So log b will come here, and it is g prime multiplied a comma b multiplied by g prime of y comma b. Fine, this number. Okay, now what is actually dA and dB? It is nothing but b to the power of c. It is nothing but the value that we are taking, the c value. Okay, so this gives me a value which divides a, let it be x. This gives me a value which divides y, let it be z. So the first point, remember what was the first point? Now x divides a, z divides y, that means xz divides ay. This was the first point that I explained, so therefore I have explained it. Okay, so log b we can simply write as gp of ayb. Okay, now if we are writing this here, log b of gp of ayb, so what will be its d function? Just think about it. What will be d function? Okay, we cannot write actually equal to right now. This is not equal to this. Okay, so what will be its d function? So just see about it. If I write gp a into y comma b, so it is nothing but b to the power of d of ay comma b. Correct? Same, just see it from above. Same. Okay, from here. Now if I just log it, so it will be d of ay comma b equals to log b of gp ay comma b. Correct? So in place of this I can easily substitute this. So it becomes nothing but g of a comma b plus d of y comma b is nothing but d of ay comma b. So this is our equation. So this is pure mathematics. Okay, the equation 1, equation 2, like that mathematics. Okay, so understand it point by point. So in this particular case we can write this here. If we log, we get these values. Fine. Now after that I am adding it out. So log b plus log a formula, that is log to the base b a plus log to the base b c, it becomes log to the base ac. So that is what I have written here. Now this was the first point that I explained, that x divides a and z divides y, so xz divides ay. So this will give me some value of xz. Okay, So what can I write here instead of this? So this is the derivation for that gp of ay comma b is nothing but this value. Okay, so if we log, so we get d of ay comma b, so I can substitute it here. So this is the first equation, and it is a very useful equation, we will see. Now let's come to what the question is asking us. Question is asking us to find the product of I equals to 1 to n of our f prime a comma I. So f prime a comma 1, a comma 2, multiply a comma 3, multiply a comma 4, multiply a comma n, so on. Okay, so this is nothing but the product of all the numbers from I equals to 1 to n, okay, for all p's that is belonging to my s prime of a, okay, g prime I comma p. Okay, so if we are true our convention, so it is q in the question. So all q's present in this g comma I comma q. Okay, so this is what the question is asking. This is the mathematical formula, mathematical function, or what the question is asking us to tell. The product of all f prime, the product of all f prime is the product of all gp for each q. The product of all gp, correct? What is f prime? F prime is the product of all gp for each prime a, for each prime factor of a, correct? And we have to find this gp for all the values of I to the n. So therefore this is nothing but the mathematical part. Now let's try to change it. So we can just simply write for all q present in s prime of a, for all I, we can simply write this. This is nothing but like, see about these are two loops in nested loops. Okay, so we are reversing it. So this becomes gp of I comma q. Now gp of I comma q can be simply written as, just think what it can be written as. Okay, so this is pure mathematics. So I equals to n, and gp of I comma q can be written as b to the power of d of I comma q, correct? We have seen this. Now if I just expand this, so it is q belonging to s prime of a. If I expand this, this will be b d 1 comma q multiply b to the power of d 2 comma q. I am substituting the I values, multiply b d 3 comma q, and so on. So this is nothing but the base is same, the indices rule. Okay, all the rules are applicable here. So d of 1 comma q plus d of 2 comma q plus d of 3 comma q, like this, correct? Now just see the equation 1 that we have written. D of a comma b plus d of y comma b is d of ay comma b. Okay, and see this d of 1 comma q plus d of 2 comma q plus d of 3 comma q. So what this will become? Multiplication of all q present in prime s prime a, b of d 1 into 2 into 3 and so on till n comma q. So just remember the second point now. Okay, just remember the second point. B of d, we have n factorial comma q. So this is what the question is asking us to solve, f prime of a comma I. So this is what the question is asking us to solve. This equation, we have narrowed down the equation to this. Okay, so for each q, we'll find the value of n factorial comma q. We'll substitute that value into our b, so we will find b to the power of that number, and we will keep on multiplying. So let's now let me just take an example now and show you how this is happening. So if we take 225 and 5, that is the second test case that we are having. So this is a and this is n. Okay, so what is the 3 comma 5 is s prime. So here q will be 3 and q will be 5. Okay, so what is the n factorial of q? Q is nothing but 3, n is nothing but 5, so it is nothing but 5 factorial 3. So how do we find this? So 5 by 3 plus 5 by 3 square plus 5 by 3 cube, okay, so on till some value becomes 0. So 5 by 3 is 1, 5 by 3 square is 0, so we get the value of 1 only. Okay, so this we will insert in this particular equation. So it will become b to the power of 1. What is the value of b? What is b? B is nothing but this g in our g prime of a comma b. Okay, and when we have this, it is nothing but g of b comma prime number, g of q, b comma q, correct, when we are calculating for fp. So b value is nothing but our prime number. What is it? 3. So it will become 3 to the power of 1. Just see this part. So for f prime of a comma b, g prime of b comma q, so our b is nothing but this, that is q here. Okay, So therefore I am writing 3 to the power of 1, which is nothing but 3. So for the first part we get the value of 3. Now for the second part, when 5 factorial comma 5, so q value is 5 now, so it is 5 by 5 plus 5 upon 5 square and so on. So 5 by 5 will give me 1 and 5 upon 5 square will give me 0, so its value is 1. So this value will be substituted in our equation, so it will become 5 to the power of 1 and it will become 5, and these all values needs to be multiplied. So 5 into 3 will become 15. So 15 is the answer for this particular test case. Okay, so I'm just writing that equation down now. So this is what our equation finally looks like. Okay, so if we just get let's example 300 comma 6, so what we are going to have, multiplication, first q is 2, so 2 to the power of whatever this comes out, so it is nothing but 6 upon 2 plus 6 upon 4, so this comes out to be what, 6 upon 2 is nothing but 3 and 4 upon 6 is 1, so this comes out to be 4, so 2 to the power of 4 multiplied by then 3, so 6 upon 3 plus 6 upon 9, so this is nothing but 1 plus 0, so it is 1, so 3 to the power of 1 multiplied by 6 upon 5 plus 6 upon 25, so it is again 1, so 5 to the power of 1, so it is 16 multiplied by 3 multiplied by 5. Okay, so 16 multiplied by 5 will give me 240, but the answer is 720. Why? So this is correct, this is correct. Okay, so 3 divided by 6 will give me 2, so it is 3 square, so it will be 9, and this answer will be 720. Fine. So this is how we are going to solve it. Now this becomes a very simple question. So what we are going to do, we just need to find out this we need to write a function for calculating these values, or that is nothing but for this part, and we need to write a function to calculate the power, q to the power, correct? So we have a power function in our program. This power function also takes mode, so it is power with mode, because 10 to the power of 9 plus 7 it can overflow, and whatever values will be there, we will be simply multiplying them. Okay, so there are two functions, first to calculate the d function, and the second thing is to calculate the power. Fine, and obviously there is a factorization function to calculate our s prime. Fine, so a factorization function to calculate s prime, a function for d, and a function for calculating the power, and finally we will be just multiplying each and every value that we will be getting q to the power, correct? So how do we calculate this? Just think about it, how we are calculating this. It is nothing but this is nothing but this prime factorization thing. Okay, so what we are doing, we are just simply dividing our n by the powers of 2 till it is divisible, then we are dividing n with the power of 3 till it is divisible, then we are dividing n with the power of 5 till it is divisible. Okay, so in a single loop we will be doing this. Okay, now let me just show you the implementation step by step. I will be implementing the code here. Okay, just see that part now. Let's see the implementation now. So in this particular case, this is a very common function, so I have already written it. That is nothing but to calculate the prime factors. Okay, so given a value of a, how to calculate the prime factors, it is a very common function. You can see the video also on our channel. Fine, so now let's begin with our logic part. So after getting all the inputs, I'll getting the prime factors in a vector. So let's have a result variable equals to 1, so this will be our result variable. Now for int I equals to 0, I less than our prime factors array dot size. So for all prime factors this loop will run. Okay, so first we need to calculate that q to the power of d function, correct? So we need to calculate the value of the d function. So long let's say what will be in the power of q. So power equals to get power, and in that we are going to pass our n, and that nothing but n and our prime number. Okay, prime of I. So it is n divided by 2, n divided by 2 to the power of 2, n divided by 2 to the power of 3, and so on. So let's just see that get power function implementation now. So in the get power function, what we are going to do is, it's very direct and very small. So long power equals to 0 while n is greater than 0. So keep dividing and adding. So power plus equals to n divided by p. Okay, and n equals to n divided by 5. So this is how the power will be calculated. So and if p value is 2 and n value is, let's say 20, so 20 divided by 2 will give me 10, so power will become 10, then n will become 10, then n divided by 2 will give me 5, so power will become 15, and n will become 5 divided by 2, which is nothing but 2 itself, correct? Now afterwards 2 divided by 2 will become 1, so power will become 16 and it will become 1. Fine, so afterwards 1 divided by 2 will be 0, so power will be 0, so power will not increment, it will remain 16 and n will be 0, and we will exit and we will return our power. So this is how this will work. Now after getting the power, that is nothing but the exponent, so now what we are going to do, we are going to calculate nothing but n to the power of, that is q to the power of this, q to the power of this value mod. Okay, so this will be our result, equals to result multiply by get power with mod. This is nothing but our power function, POW, like that. Okay, but with mod. So whatever the prime value was to the power what we have calculated, and with the mod value, that is 10 to the power of 7, 10 to the power of 9 plus 7, so 1 2 3 4 5 6 7 8 7. Okay, and we are going to mod this value, whatever the multiplication is, with 10 to the power 9 plus 7 as well. Fine. And finally we are going to print the result. Now we need to calculate, we need to implement this function, that is get power mod. So this is nothing but modular arithmetic part. So what do we do in that, is nothing but x to the power of y mod p. Okay, so this is also you can find easily on the internet. So I'm just going to write this function down now. So long result equals to 1. Fine. So x equals to x mod p, x mod p. If x equals to 0, then simply return 0. Now this is nothing but the power function. Okay, so just let me write it down quickly. Finally return result. Fine. So this will calculate the power with the modulus p, and it will return me the result. Fine. So what we have done here is, first we have calculated using the get power function the value of this n factorial by q. Now q is our prime factor, so after getting this value, which is represented by power in the code, we are calculating q to the power mod 10 to the power of 9 plus 7, and we are multiplying this for all q's into our result. Okay, for all prime factors, for all q's in a loop. Okay, so in a loop, this is nothing but our loop for all the prime factors, calculating the power every time, and then calculating the q to the power of this value and multiplying each and every time. So this will give me my f. Okay, so this was the implementation for this particular question. Fine. So just see again if you are not able to understand the mathematics part of it. So this is purely a mathematics based question. Okay, we have to get this equation, and after getting this equation, writing the code is very easy. And the prerequisite obviously was knowing about the trailing zero function. Okay, thank you.